So we have a box of 12, so N is equal to 12 ink cartridges, and let's see, what do we have? 9 have ink, 3 do not have ink, and what we're going to do is, what are we going to do? Let's see, the cartridges are drawn in succession without replacement. How many ways can the first two, so we're going to choose 3 cartridges, right? 3 ink cartridges are to be drawn. So we're going to choose 3. So R is equal to 3 here, and what we want is this. What is the number of ways that we can get the first 2 having ink and the third one not? So here's how I'm seeing this. I want the first one to have ink and the second one to have ink and the third one not to have ink. So I have ands. So I ask myself, are these independent? And they are not, because we have without replacement. So the sample space is going to change. So here's how I'm going to write this. I've got the first having ink times the second having ink times the third not having ink. And what's the probability that the first one has ink? Well, there's 12 cartridges in here, and 9 of them have ink, so 9 12s times. Now, there's 11 cartridges left because we've already taken one and we're not replacing it. And how many of those have ink? Well, the first one we got has ink, so there's only 8 out of 11 left. Now, I want the third one not to have ink. There's only 10 cartridges left, right? Because we've already used 2. And how many of them do not have ink? Well, 3 of them don't have ink. So I'm looking at this. I'm looking at 9 12ths times 8 11ths times 3 tenths. And when I did that on my calculator, I got 0.1636 when I round off the 4 places.